check this out. So this is the 2 transistor series gate with the tip 120 and the load limiting resistor of 7.5 ohms through the diode, and just going into an 8K, and we've got a potentiometer. So that's the circuit. Potentiometer's down here. Just lets me kind of adjust the total voltage going to the base of the tip 120. That's not there. That's the resistor in place of this. That's the 7.5 load resistor. What we can see here, we've got a 12 volt power supply, 1 amp going through it, and we've got resolution all the way up to 200 kilohertz on the pulse. It goes as high as or higher. Goes all the way up to the megahertz. There's 1 megahertz right there. So there's some adjustment with the amplitude of the input signals, and I can kind of work around the wave kind of breaking up there. But notice one thing. Look at that beginning pulse. Look, there's a crappy starting pulse, isn't there? Oh, look what I can do. I can just make it a whole one. Or half a one. I can tweak it to where they're all in line. The same with the gate. Really smooth transition from the gate. This is at 200 kilohertz. There's a little bit of noise going on in there, but it's not so much if I... Oops. Take it back out. Let's go past trouble. It's pretty neat. And it's reversible, so I can go to the high frequency on channel 1 and down to the gate on channel 2, and it's reversible. I just have to adjust my amplitude to clean it back up. The pot over here helps a little bit. So I'll switch back the other way, which seems to be a little bit better. Something about the physical location of the pulse transformer versus transistor versus the gating transistor seems to have an effect on the amplitude of that kind of mixing that's going on there. Let's go back out a little bit. So this is with square wave 50%. I can switch the duty cycle up on the gate, obviously, and do that. I can switch the duty on the pulse and do that. And then I can use my other functions like sine wave, so I can get square gate, sine wave pulse, unipolar pulse, or I can get square pulse, unipolar gate. I can have unipolar both. Can't get that settled down. The scope is acting up on me. Let me see if I reset it. So again, playing with the amplitude, I can kind of mix that in. So blue channel 3 is the resistor right above the 2 transistors. So it's at the cathode of the pulse transistor, and then yellow is at the load, across the load to ground. And we've got more than 12 volts got 35 peak to peak, as high as 33, min negative 240. Base is right at 0, so there's some noise that's going negative that's picking up on. But there's only 12 volt input, and we've got triple voltage at the load. Triple voltage. Okay, you can get it higher if I, yeah, see there's 50 volts. If I turn the pot all the way up, I can get it as high. You know, the wave goes to crap, but at least the amplitude has gone as high as 50 volts. Or 12 volt supply. Quite interesting. Yep, just so we got a 10K here. There's 10K on the top and the variable 10K on the bottom. I thought maybe that it might be good to have a 10K pot here also, so that it really could adjust where that reference sits, and that would really control the bias and where the switching happens at. So I could shift the modulation up and make it occur up higher up in the above 0. So let's see, we shall now try and hook this to a transformer now and see what kind of output we can get. Above all, I'm pretty impressed with the gain just from that little bit. Remember, this 10K means 1.6 milliamps max goes to the base of the tip 120 at 12 volt. Goes to the base. See, I used 12 volts on that. 12 volt also fed the base basically, but then it's pulled down by this. So this is the negative bias, and this is the positive kind of swing bias. But 1.6 milliamps at 10K goes through here. Making that a pot obviously would make that go way up and could probably blow this out. But it might be worthwhile to have a 5K and a 0 to 5 here, which should still limit us to like 3 milliamps through here. The load limiting resistor is going to prevent any more current than 12 volts and 7.5 ohms, which was roughly 1.6 amps. So it's ironically exactly HFE of 1000 on the gain here. So it seems like it works out pretty well.